Hey guys, this is chapter P, section 4. We're going to do this in a few different parts like we've done the other things. So this is part A. We're going to start talking about factoring, reviewing. All right, guys, today we are talking about two parts of factoring. Again, like I just said, there's a million different ways, but today we're going to talk about GCF, greatest common factor, and then we're also going to talk about difference of two squares. But GCF should be the first question you ask yourself every time you have a factoring problem. Is there a number and or a letter that both or all of the terms in your expression have in common that you can take out? You are not going to be changing the value of any of these expressions. We're just changing the way that they look. So I look at this first example here. I have two terms. I have 6x cubed and a negative 4x. Terms are separated by plus and minus signs. So the first thing I notice is that, 6 and 4 are both divisible by 2. So I can factor out a 2 from both of these. And I do notice that they both have an x, so I can take out an x. So what you are factoring out, what the greatest common factor is, you put out in front. You do not just take it away, remove it. It's still in the expression, it's just in a different spot. So as we divide out, 6 divided by 2 leaves me with 3. X cubed divided by x is x squared. Then I have a negative 4 divided by 2 is going to give me minus 2, and x divided by x is just going to cancel out. So this expression here, 2x times 3x minus 2, is the exact same thing as 6x cubed minus 4x. Same exact thing. This is just a factored form. Whatever you take out, you have to account for. You have to leave out in front. Don't forget about that. So as we look at these next examples, the first thing I do is I say, okay, is there a number that all these have in common? What do you guys notice here? It leads with a negative sign. We don't ever want our expressions to have a negative out in front. So if we lead with a negative, then we've got to take a negative out. So the first thing I see is I say, all 4 of these terms are divisible by 4. So I'm going to divide out a negative 4. Can I divide out a variable with that? No, because 16 doesn't have an x with it. But I can divide out negative 4. So I'm going to rewrite this with my negative 4 out in front. And then I'm going to divide negative 4, just going to leave me with x squared. 12 divided by negative 4 is going to be minus 3x. And then negative 16 divided by negative 4. Negative divided by negative is a positive, and then I have my 4. So I'm left with negative 4 on the outside, x squared minus 3x plus 4 is my factor form. So looking at number 2, I'm going to look for anything in common, number-wise and letter-wise. So I notice, all 3 of these are divisible by 3. And I also notice that each term has at least one x in it. So I'm going to divide out from each term 3x. We're going to write it out in front and then simplify. 3x cubed divided by 3x is going to leave me with 3x squared. Negative 6x squared divided by 3x is going to leave me with minus 2x. And then 9 divided by 3 is going to leave me with just 3. So there's our factoring form there. And then I'm going to look here and I say, okay, remember, terms are separated by plus and minus signs. So here is the plus sign that's separating these things. If you guys notice here, x minus 2 and x minus 2, they have those in common. So I'm going to rewrite that out in front, x minus 2. And then I'm going to divide each term by what I factored out, x minus 2. So this cancels. This is going to leave me with 2x plus this cancels, and I have 3. So when you divide out what they have in common, the x minus 2, you're left with 2x plus 3 on the inside. All right, and now I'm going to look at this and say, all right, well, I got a lot going on in this problem. Let's look at it for a second. All right, so I see this expression. This says x plus 3 quantity squared. What this really means is x plus 3 times x plus 3. And then I have minus 4 times x plus 3. So again, you guys notice anything that is separated by plus and minus signs. Here's my separation is right there. So I have an x plus 3 in both of these terms that I can factor out. So x plus 3 and x plus 3. So I'm going to write it out in front one time because that's what I'm factoring out. When I divide out here, then I'm left with x plus 3. And then I divide out here. And then this is minus 4. So I see, I can now combine a little bit here. So this is x plus 3 times x minus 1. And that's what we did just to simplify. These two things mean the exact same thing. When we talk about the difference of two squares, when you have two terms of a binomial and they're perfect squares with a minus sign in between them, you have the difference of two squares. You're going to square root the first and last terms. One parenthesis gets a plus sign, one gets a minus sign. So if I look at this and I say, okay, I have x squared minus 4. Well, is x squared a perfect square? What times what gives me x squared? X and x. What times what gives me 4? 2 and 2. So though both terms are perfect squares, so I'm going to write two parentheses. Each of them gets an x in the front, a 2 at the back, and then a plus and a minus in the middle. Doesn't matter if you put plus first or minus first. Doesn't matter. So we look at this and I say, okay, is this a difference of perfect squares? Well, let's talk about it. What times what gives me 9? 3 and 3. What times what gives me x squared? X and x. And what times what gives me 49? 7 and 7. So I do have the difference of perfect squares. Difference because there's a minus sign there. So I'm going to write my two parentheses. In the front of each parenthesis is going to get the front part, so 3x. The back of each parenthesis is going to get the back number, and then a plus sign and a minus sign in the middle. Again, it could be plus minus or minus plus, whichever you guys want to do. Difference of perfect squares, let's check. What times what gives me 36? 6 and 6. What times what gives me x squared? X and x. What times what gives me 49? 7 and 7. And what times what gives me y squared? Y and y. I have that difference in the middle. I have the minus sign, so my two parentheses are going to have 6x in the front, a 7y at the back, and then a plus sign in one of them and a minus sign in the other. Again, look at 7. Is this the difference? Yes, it is a difference because it's a minus sign. Are these perfect squares? Well, let's go through. What's the square root of 4? It's going to give me 2 and 2. What times what gives me x squared? X and x. What times what gives me 100? 10 and 10. So I say, okay, I have 2x plus 10 and then 2x minus 10. But now I look at this and I say, wait a second. That doesn't seem as simplified as it possibly could be. What did I tell you at the beginning, guys? The first question to always ask yourself, is there a GCF? We would have caught that if we did that from the beginning. I know a lot of you looked at this and said, wait, can I divide everything here by 2? You absolutely can. But what I want you guys to get in the habit of doing is to find that, see it from the very beginning. That's when it's the most important. So I'm going to look here and say, wait a second. Is there, we're going to do the same problem right over here. Again, I want you to see you can still get the same answer if you do not follow the steps the same way every time. But it's best to do the steps the same way every time to minimize your work. If I look at this, I say, okay, wait a second. What do these two have in common? Well, do you guys agree with me that they both could be divided by 4? Yeah? Absolutely. Take out that 4, then you're left with x squared minus 25. Is this the difference of perfect squares? Yes, it is. You have a minus sign. You have x and x, 5 and 5. So this becomes 4 times x plus 5 and x minus 5. Now, if you did not get that, like if you notice here, you'd have to divide this one by 2 and this one by 2, right? So if you did that, you would have ended up with x minus 5, and then you would have had to take those two 2's and multiply them together, and you get your 4. Right? So yes, you could have done that, guys, but it's much easier to find the GCF first. All right, next thing. Well, I look at here and I say, okay, is this the difference of perfect squares? I do agree with you guys that 25 is a perfect square, x squared is a perfect square, 36 is a perfect square. But this is not the difference. This is addition. So this is not factorable. We will get to stuff like that later on, but it's imaginary. So we'll talk about that later. Remember, it has to be the difference. Has to be difference. If it's not the difference, then it would be not factorable. That's where that came from. All right, here's some more examples we're going to factor here. Well, let's talk about this. X to the 8th minus 1. What can I do with x to the 8th minus 1? I could break this down, and x to the 4th minus 1, x to the 4th plus 1. All right, that'll work. That's good. Now I say, okay, can I break this down anymore? Is anything the difference of perfect squares? Well, I see a minus sign, so that's going to give me a difference right here. So I can break this down, x and x squared, and 1 and 1. So this is going to give me x squared minus 1, x squared plus 1, and then I still have my x to the fourth plus 1. And again, guys, we're always trying to simplify as much as we possibly can. So I'm going to come over here and figure out this for a second. I have x squared minus 1, x squared plus 1, and x to the fourth plus 1. All right. Anything that has a difference, a minus sign in the middle, we're in its perfect squares, we can break down a little bit more. So x squared plus 1, can't do anything with. X to the fourth plus 1, can't do anything with. But this is another difference of perfect squares. This would be x plus 1 and x minus 1. So we have broken down as much as we can. Can't do anything here because those are plus signs. If it was a minus sign, you absolutely could. All right, let's look at number 10. First thing we ask ourselves, is there a GCF? There's no GCF, but I do see some big old numbers here. 625, x to the fourth. Those are, I could break those down. Absolutely. What could I break 625 into? Well, 25 times 25. What could I break x to the fourth into? X squared. Good. And then my negative 1 would just be 1 and 1. So I would have two parentheses here. It would be 25x squared plus 1, 25x squared minus 1. So now I say, okay, are there any difference of perfect squares stuck in there? 25x squared plus 1 I cannot do anything with because of that plus sign. Yes, I agree, 25 and 1 are both perfect squares, but I can't do anything because of that plus sign. But here, I can break this one down. What would my 25x squared become? 5x and 5x. What would my minus 1 become? Minus 1 plus 1. So we always keep simplifying, keep breaking down as much as we possibly can. All right, let's look at number 11. GCF. Is there a greatest common factor? Is there a number or a letter that is in common here? Absolutely. I can divide this by 3. So I'm going to bring this 3 out in front. 3 divided by 3 is 1 minus 12 divided by 3 is going to be 4x squared. What do you guys notice here about this problem? The beauty about this problem is that, excuse me, we have broken down into perfect squares. I have the difference of perfect squares. Difference, minus sign. What's the perfect square of 1? Well, 1 and 1. What can I break 4x squared into? 2x and 2x. So this is just written backwards, and that's quite all right. I still have my 3 out in front, and I have two parentheses. I have a 1 in the front of each parenthesis. I have a 2x in the back of each parenthesis. I have a plus sign and 1 and a minus. And then I look and say, okay, can I break down any further? And no, I can't. It would just say just like this. All right, let's look at number 12. Number 12's little, not funny looking, we won't say that, but it's a little different. I have my first term. What would I break this down into? Well, this would be x plus 2 and x plus 2, right? Because there's two of them. And then my y's would be a y and a y. So I have the difference of perfect squares. So I would have x plus 2 plus y in my first parenthesis, and then I would have x plus 2 minus y in my second parenthesis. All right, same thing here. This is the difference, minus sign, of perfect squares. I have x plus 1, or I'm sorry, x minus 1, x minus 1. Here I have, what times what's going to give me 9? 3 and 3. What times what's going to give me y to the fourth? Y squared. So my two parentheses would be x minus 1 plus 3y squared, and x minus 1 minus 3y squared. All right, 14. GCF, is there a number or letter that's going to go in here? No. Is this the difference of perfect squares? I have a minus sign, so let me check and see. That's good, that's difference. Are either of these perfect squares? Wait a second. Is there a GCF that goes into this? Absolutely. Again, if you didn't catch it, no big deal. You're going to have to catch it on the back end. Make sure you get it out. But what number goes into both 81 and 36? That would be 9. So I'm going to bring my 9 out in front. 81 divided by 9 is 9. excuse me, 36 divided by 9 is 4, so x squared. Now, do I have another perfect square, difference of perfect squares hidden in here? Absolutely. I absolutely do. 3 times 3 is going to give me 9. 2x and 2x is going to give me 4x squared. So when I factor this out, I have my 9 out in front, and then my two parentheses are going to have a 3 in the front, a 2x in the back, and a plus and a minus sign in the middle. Does not matter which one has the plus, which one has the minus. Just make sure you got it. All right, let's look at number 15. GCF? No. Is this the difference? Yes, I have a minus sign. Are these perfect squares? Absolutely. X squared is going to give me x to the fourth. 16 could be broken down into 4 and 4. Y squared would be y and y. So my two parentheses have an x squared in the front. They have a 4y in the back, and a plus sign in one, and a minus sign in the other. Now I look and say, can I break this down any further? Well, can I in this one? X squared would be x and 4 would be 2 and 2, but this y squared, it doesn't say y squared. If it said y squared, then yes, you could break this down again, but since it's just y to the first power, there's nothing else to break down. There's no more other than what you just have there. Here, guys, we're going to talk again about another special pattern. It's a perfect square trinomial. Sometimes these are a little harder to identify, so we got to go through and make sure we're thinking, okay? In our perfect square binomials, it was the difference, a minus sign, and there was only two terms. There was an a term and a b term. In a perfect square trinomial, tri means 3. You're going to have 3 terms, okay? Tri means 3. So the way that you would test to see if something is a perfect square trinomial, you square root the first and last terms, okay? That's good. Then the double product is the middle term. What does that mean, double product? All right, so let's look at this. Let's check to see if this is a perfect square trinomial. Is the first term a perfect square? Yes. X and x. Agreed. Is the last term a perfect square? Yes. 5 and 5. If I double the two terms together, does it equal the middle term? Well, 5 times x is 5x times 2 would be 10x, right? So yes, this is a perfect square trinomial. You take the sign from the middle term. So what this would become is x minus 5, and how many of them do I have? 2. It would be x minus 5 quantity squared, x minus 5 to the second power. So now I'm going to look and say, okay, first of all, is there a GCF? Is there a number that can take out of 16, 24, and 9? No, some of you would try and say 3, but that's not the case. So let's look and see if this is obviously not a difference of perfect squares because there's 3 terms, not 2. So let's see if this is a perfect square trinomial. Let's take the first term, 16x squared. So I could break that down into 4x and 4x. Let's take the second term, which is 9. I could break that down into 3 and 3. Okay? So if this was a perfect square trinomial, the first and last terms are perfect squares, and then the middle term is the product of the first and the last doubled. So 4x times 3 is 12 times 2 is 24. So yes, this is a perfect square trinomial. We're going to keep the sign in the middle. So this is going to be 4x plus 3 quantity squared. All right, same thing. Let's look at 17. Obviously not the difference of perfect squares. There's no GCF, so let's just see. Let's break this down. Does the first term break down to a perfect square? 3x and 3x? Absolutely. The last term is 5 and 5. So let's see if I take the product of the first and the last and double it if it equals the middle term. So 3x times 5 is 15 times 2 is 30. So we see that yes, this is a perfect square trinomial, and we're going to take that sign in the middle. So it's 3x minus 5 quantity squared. All right, next one again, no GCF, so we're going to say, okay, is the first term a perfect square? Yep, 2x and 2x. Is the last term a perfect square? Yep, 1 and 1. So let's take the product of the first term times the last term times 2. See if we get the middle. So 2x times 1 is 2x, times 2 is 4x. Perfect, that's what we want. We take that sign in the middle. So my parentheses is 2x plus 1 quantity squared. That means I have 2 of them. All right. Ooh, man, now my numbers are getting a little bigger. Is there a GCF with 36, 84, and 49? No, but let's just get in the habit of looking. So let's take, is the first term and the last term, are they both perfect squares? So 6y, 6y, 7 and 7. So if I multiply the first times the last and double it, do I get the middle term? Well, 6 times 7 is 42 times 2 is 84. That works. So that sign right there is going to be my sign in the middle. 6y plus 7, quantity squared. Okay, this last example, let's take a look at it. Let's go ahead and put a V right here. Let's make this problem work out just the way that we want it to. Okay, so we come to number 20, and it says to factor. So you say, okay, is this the difference of perfect squares? Well, obviously it's not, because it's 3 terms. There's a plus sign. So let's see if this could possibly be a perfect square trinomial. So I'm going to take my 9u squared. I have 3u and 3u. I'm going to take my last term, 16v squared, 4v and 4v. Now, if I take the product of the first term times the last term and double it, do I get the middle? So 3u times 4v is 12uv times 2 gives me 24uv. That sign right there goes in the middle of my parentheses. So I have 3u plus 4v quantity squared. So there you guys go. If you could please submit these notes to the assignment on Canvas. Make sure that you turn them in so I can see that you guys did them all. And then begin working on your homework. And any questions you have, I will answer as soon as I get back.